varroa mite is a specific parasite of the honeybee, Apis mellifera. It actually switched from the Asian honeybee, Apis cerana, about 100 years ago to our Afro-European honeybee. And so in terms of evolutionary time, this is relatively short. And that's why our bees are so affected by this, because they haven't, in an evolutionary sense, they haven't had a chance to develop through selection natural defenses. People are working on that. There's a lot of very intensive efforts to find bees that are naturally resistant. The mites are a problem because they parasitize both the adult bees, the workers that you see coming and going, but also the brood. This is the developing young bees. And so a bee can be parasitized its whole life by this varroa mite. And the mites actually puncture the bee's cuticle and leave behind a wound that doesn't close. And this really weakens the bee's immune system, and it also is obviously an opening where pathogens can get into the bee. So usually very heavy varroa infestations also correlate with other bee diseases. And that's why it is such a problem, because it leads to weakening of the bees, and that's what then ultimately makes them collapse during wintering. We don't know the actual protein in the mite to which the compound binds, or a collection of proteins. We know that paralysis usually involves the nervous system of the mite. And so we just recently got funding from Genome BC to, in collaboration with Dr. Leonard Foster at UBC, to actually investigate exactly that question. It's how does this work at the molecular level? This is very important. How will this be commercialized? That is another question. These field trials are an important first step, because we have to prove that the compound not only works in the lab but also in the field, in a real beekeeping situation.